Hello, this week I said that we'd be looking at longer samples, so doing things like cutting them up, beat slicing, granular synthesis, stuff like that. But first I thought it would be good to have a quick look at functions to get to grips with what they are and how to deal with them, because we'll be using some functions to manipulate samples, longer samples. And it'd be good to start with a really clear example before getting on to the weird beat mangling. So let's have a look at some code. So this is the worksheet I've made for you. So I thought I'd just step through this to see how that goes. So what the function which we'll look at is called every. Every is a function that takes another function as one of its inputs. It's what computer scientists would call a higher order function because it does things with other functions. So every is good for things like if you've got a pattern and you want to do something every, say, third cycle, like speed up the pattern, but only every third cycle. Every makes it fast to do that nice and quick. Let's start with a simple pattern. So this is the example I've got. So say we wanted to do that, make it twice as fast, but only one cycle out of 3. This is how we do it. So it plays it normally twice, and then the third cycle, it plays it twice as fast. And you actually, because it's going twice as fast for one cycle, it will actually play it twice in the space of one. So it ends up playing it 4 times every repetition. So every is the function which we're looking at here. Every actually has 3 inputs, one being the number of cycles between each application of the function. That's the first parameter. The second parameter is the function you want to apply to the pattern, and the third function is the pattern itself. So the first input is this 3 just on its own. The second input is this function, which is wrapped in parenthesis. And the third is this pattern, which is separated out from the rest by using this $. So this is what makes sure this gets all worked out before it is passed to every as its third parameter. So if you think about this function as having like 3 slots as inputs, here's the first slot, here's the second, and here's the third. Later on in this file, it just goes over the different ways of grouping together these things so that they become a single input. Like this is a single input because it's wrapped in parenthesis, and this is a single input because this $. Separates it out. You can only use the $. on the end, which is why here I'm using parenthesis to do that. Let's return to that in a sec. Let's instead look at some other examples. So here it's doing every third repetition, go twice as fast, and this is what it's working on. You find functions generally have a pattern as their final input. Another word for input is argument or parameter. I might say those sometimes. I'll try and standardize on saying input, but if you hear me say parameter or argument, it doesn't mean I'm having an argument with someone. It just means it's another word for input. So functions all have inputs and outputs in Tidal. The input is this, and the output is a new pattern, which then gets passed to D1 in this case. Okay, so instead of fast2, like here, all I've done here is replace hurry with fast with hurry. So with every, the function has to take a single input, a single pattern as input, and then has to return a single pattern as output. And that's what hurry2 does. It takes a pattern and makes it twice as fast, but also pitches it up. But the same is the case of rev. So this is reversing the pattern every third repetition. So rev doesn't have any arguments apart from the pattern that it's going to reverse. So that works as an input there. It's just a bit funny having something that takes an input but is itself an input for something else. That's the strange thing to get your head round. But actually, if you just read it, every third repetition reverse this, it kind of reads as human language. Here it says that you don't need to put parentheses in this case. So because rev is a single word, it doesn't need to have brackets around it. This does because it's two things. So hurry needs to know how fast you want to make this sound. And because you need those two things there, in order to treat it as a single input, you have to wrap it in parentheses, so that every knows that this is the function. Without that, you just get an error, because it'll say every 3 hurry. That's not the right kind of pattern. That's not the right kind of function, because on its own it takes 2 inputs, and every just wants one that takes 1 pattern as input. And so then, yeah, that'll work. Hopefully, yeah. So that works. This works without the parenthesis if it's a single word, the function. So that is hopefully becoming fairly clear, but you can play with it yourself. This is a nice trick to do. So say you had this pattern and the same as this one, but you wanted it to sound distorted. So you did that with squiz. That sounds quite strange. Sorry about that. But you didn't want that to happen every time. So what you could do maybe is, I don't know, pattern it out like this. But maybe you just don't want any squiz at all. So the weird thing you can do is actually treat this as a function, because this is like a thing that you do to a pattern. You use the hash to combine this pattern with this pattern, this squiz pattern. So what you can do then is take that, I'll cut it, and if I do every 3 and then in parenthesis again, I do this, and also add the dollar, then hopefully, yeah. You can hear what's going on there. There. So, yeah, that's what I just typed. So that works. You can take a parameter, a control parameter like squiz, and use it with every to make it conditional. Another good thing you can do is add more than one of these everythings. So let's see this. So now every second cycle is doing the hurry 2, and every third cycle it's doing the squiz 5. So it'll actually repeat every 6 cycles. And you can just keep adding these. So now, yeah, it'll take quite a while to repeat exactly the same because there's 4, 2, and 3 interacting together. Okay, this is interesting. So this works basically because every 3 squiz 5 takes this pattern as input and returns a new pattern that's transformed. And so it passes it back, and then every 2, hurry 2 takes that pattern and transforms it some more. And then finally, the result of that, every 2 hurry 2 transformation gets passed back to every 4 rev, which then returns the final pattern to D1. So it kind of goes backwards up the chain. There we go. And then it talks about the exact meaning of, it'll go through again why there's a parenthesis here, this doesn't have parenthesis, and why there's a dollar here. It points out that this is the same as this. You might even prefer to do it that way. You might even prefer to always use parenthesis everywhere. Some people like that, that's fine. But with longer patterns, often it becomes quite hard to keep track of where the parentheses are. So at the moment, this is quite nice that it underlines it for you and helps you match them up. But once it gets longer and longer, it can get more difficult. And so what I tend to do is, for the final parameter, use the dollar to separate them. Then you don't have to remember that. That's really almost all about what the dollar's about. Okay, and that's the end. So I'm going to try and make these videos a bit more focused, a bit shorter. I'm not sure how successful I was this time. 13 minutes, not that successful. And try and make them snappier and more hands-on with more examples. So we'll see how that goes over the next week. If you keep giving me feedback, then that'll be really useful for me. And because it's the first time I've run a long-term course like this. So yeah, see you for the next video when we'll start looking at chopping up sounds and making weird noises. So yeah, see you soon.